So let's continue with our lecture 15 on inheritance and class objects. So here's the familiar interface with code blocks. And you can see I've created lecture 15 on inheritance, and it gives me this main.cpp, which I've already filled in. Now, here in the background is Adam, my editor of choice, and we have a point object, a circle object, and a cylinder object, all based on those UMLs that we did in the last lecture. Now, when you create these H files, it's a little tricky as to how to do it in code blocks. So you would go File, New, and don't call it an empty file, but call it a file, because then it'll ask you what type you want. And we want a C++ header. So if I select that and hit Go, okay, I'll accept all of this. I give it a file name, and it's going to want the full path name. So if I select this box here, and here's the folder on my desktop that I've created, and this is going to be point.h, and I already have a point.h, so I don't want to jam up what I've already got. So let's see. Cylinder inherits from point, cylinder inherits from circle, circle inherits from point, what inherits from cylinder? Well, a cone object. We're not going to create a cone object, but I want to show you how we create it. I will hit save and finish, and over here on the right is a headers folder. The cone is in there, so are the others. The cone is only appearing now because it's what's been selected. So if I do File, Open, and I drill down to find, what is it, lecture 15, let's say the circle. It always brings up another window, I don't know why. There's circle, but it doesn't show that it's living here. Like I said, it's funny. It's one of the crazy nuances of code blocks on a Mac, go figure. But anyway, here's everything for us, and that's why I'd like to do it here, the editor. In fact, if I run this right now, it compiles fine, and it runs, and I'll go through what this output is doing in just a second. Okay, so first things first. Here's the point object. Again, we have these directives that say if point hasn't been defined, define it now. We'll need IOStream and a namespace. The IOStream will be for this output stream friend object, and what that means is we're overloading the output operator, and it's going to actually print out what this point object is when we send it to output, which is a nice little thing. I'm not going to ask you to know the details of it. In fact, I give this to you free of charge. You don't necessarily have to use it, but you might want to create something in that point or toString method. Okay, so here's some of our public information. Point, int x, int 0, and int 0. This is our x and our y. As I said to you, here's a nice, convenient, sneaky way of creating a default constructor and a constructor with parameters all in one line. If the end user doesn't put anything in here and just says point, paren, it will automatically set them to zeros. But if he does do something, then they'll be set to whatever it is that he inputs. The set point is like a helper method down here. It'll just set the A and the B depending to what it is. Here's the set point method itself, all written out, full blown. The getX and getY, it's one simple line of code. So because of that, we can write it here in one line like this. You'll notice there's no getX or getY inside this point.h file because we took care of it here. Since it's small enough, we can do that. Okay, again, another freebie I've thrown in that you can use. All right. And here's all the full-blown functionality code. Here's that overloaded operator. It's going to output the x and y points, and more to come, because each new overloaded operator is going to print out not only the x and y of the object, but more information. Okay, so here's the point. Here's the circle. Okay, scroll to the top. Okay, it's an H file because we've included the class construction information and all the functionality code. If it's not defined, then let's define it. Output treatment IO manip, because we want to format the radius. Since it's of type double, we only want to print out a certain number of decimal points. Include point H, which we already had. Okay, this is the inheritance. Class circle colon public point. That means circle inherits from point. So anything in point now, circle has access to, at least in terms of the public methods. Okay, here's the public constructor. We create a radius and then the x and the y. Once again, a sneaky way to do a default constructor with all values set to 0, and also a constructor in which I want to give it a specific radius and an x and a y coordinate. Getters and setters. Okay, and here's the code here. Okay, now since we inherited from point with that colon here, public point, down here when we create our constructor, we have to also include it here at the end. And what are the parameters that we're sending into our circle? Well, our x and y coordinates. We're calling it a and b here. And because they're declared of type int, we can just say a and b here. And what's going to happen is the radius is going to be set locally here, and point is going to be set as a call to the parent class. So whatever I set here, point's going to know about, again, thanks to this business. Okay. Set radius. Okay. Radius equals, and we use the ternary operator here, which means we test this predicate. If it's true, do this. If it's false, do this. So if radius is greater than 0, that meant radius is a positive commodity, then set it to R. If it's not, if it's negative, set it to 0. So we're now forcing the construction to not have a negative number. And I said here it's the same as this. In one line, we're now doing 8 lines of code. I do like this a lot, but only use it if you know what you're doing. It's the only ternary operator in the language where it takes 3 parameters, but it's the same as this. I will leave this in here as well. This is certainly much more clearer, but this is kind of slicker. Okay, here's the getters. Get the radius, get the area, pi r squared, get the diameter. It's twice the radius. Get the circumference. There's 2 ways to return it. I can return twice the radius, but since twice the radius is diameter, why not say get diameter? This should yell at me that I have 2 return statements, but CodeBlocks doesn't yell at me. So I'm going to comment one out. I'm going to keep, again, this little more convenient one. Okay, now here's the friend output operator. Since we already have the point, we will output the center by referencing the point that the parent comes from, which is the &c, that the point cast, or rather turning the circle to a point object, which means we only worry about the x and y. And then we get the radius by setting some flags and showing the point only 2 decimals of the radius. And we return the output, which will also cascade again when cylinder comes to be called. Okay, here's the cylinder object. Again, declare cylinder. If it's not defined, define it. We inherit from circle, or rather include circle, which had already included point. And here we go again. The class inherits from circle. Again, this is the key components how you can identify inheritance from some other class. And here we go again. 4 parameters. Again, a default constructor. I set a height and a radius and an x and a y. If I don't set anything, they all become zeros. Otherwise, I do set something. Okay, setting height and getting height is local. Getting surface area, and then getting the volume. Here's the height. That's the only different variable that we need. Everything else is done for us thanks to circle and circle's inheritance point. Okay, just like before, here's our constructor with height, radius, x, y. And over here, we're making a call to the parent class with radius, x, and y, because that's what the circle needed. And when the circle gets called, it's going to call its parent, which I guess would be this cylinder object's grandparent. All we have to do here is set the height. Okay, so we set the height here again using the ternary operator. I just explained it in the previous .h file. Here's the height of the cylinder. Here's the surface area. Surface area, again, imagine a can. You've got a top and a bottom. Well, they're circles. So top and the bottom is that. What is the, if I wrap around the can, what is the can's, like a can of soup, the label. How much surface area is that, how much area does that label take up? Well, it's a circumference times a height. So 2 pi r is the circumference. We could have said circle dot get circumference and multiply it by the height. Okay, little mathy, little geometry, but never hurts anyone. The volume is that circle bottom area times its height. Again, we are cashing in on what the parent has already done for us, and we are now just adding something simple. So we get the parent area and we multiply it by the height. And then we output everything. We'll output a cast of the circle object. We cast the cylinder as a circle, and when the circle was called, it cast itself also as a point. Again, it's a little thick to understand. Just say, okay, I get it, it works. Okay, so let me just make sure I save these. These little blue dots mean that they are unsaved, and I think everyone's good. Okay, so back to code blocks, and yes, I edited it outside the region, and compile. Taking a little bit longer to compile than usual. There we go. And we run it. So what's the output look like? Well, let me kind of come here to the main and see if I can't get the terminal window open. Main will create a cylinder with a height of 5.7, a radius of 2.5, and coordinates 12 and 23. So there it is. It's echoing back our coordinates 12 and 23. Radius is 2.5, height is 5.7. Okay, fine. So it gives us our x and y coordinates. It reports the x and y coordinates. And let me kind of move this down. It says the new location, because we've now changed it. We reset the height, radius, and we reset the point. So it says the new location, and also the parameters are, the center is 3, 3, because I made a call over here to get the cylinder information. And again, by doing that, that's what calls the cylinder object information, because we called it sil. And by outputting it like that, that's what that output friend string does. For you Java programmers, think of that as the toString method. We print out an object. What's its toString that we want it to print out? So C++ does it differently. Where's my terminal? There we go. Okay, so it gives us a center, a surface area. Okay, yeah, this was, I think I went down a little bit too low. Here's the new location, radius, height, and cylinder R. There's the center on the new line. The radius I don't see. Is it over here? Oh, it's giving me the radius from the output from the friend operator. The area of the cylinder is 380.53, new line. That's a surface area. And we changed the cylinder's point. So right here, I'm showing that we can use a pointer reference, a point object, as a cylinder, and it thinks it's a point because the cylinder does in fact have a point. So when I do this ampersand pref, I'm casting cylinder as a point. I'm stripping everything out that's not a point and giving it to this ampersand pref, and the pref will print out what its point is, which we now know is 3, 3 because we changed it right there, 3, 3. Okay, if I cast it as a circle using an ampersand cylinder ref and print out that information, it's printed as a circle. Again, center is 3, 3, the radius is 4.25, the area of that circle is 56.74, and we return 0. Okay, so all of this is a grand tutorial, by no means all-inclusive. There's always so much more that we can talk about. And like I said, I just did a cone object. A cone is a type of cylinder, except it has totally different information in terms of its volume, its surface area, which is based on its slant height, fun with mathematics and geometry. But I think this is a good intro to the inheritance. Like I said, we've now got polymorphism and virtual and abstract keywords to use on our functions as well. Okay, so let me terminate this. I'll terminate the video, and again, stay tuned for the future videos in this series.